When we went through the process of solving a quadratic via square roots, we talked about the fact that there are some equations that are not set up to solve with square roots, and those were equations that had a linear term like this. Today we're going to see how we can use a process called completing the square to force those equations to have a square that allows us to solve via square roots. So here's our first intro example. Given that the left side of this equation is a perfect square trinomial, solve using the square root method. So we're going to factor this left-hand side. I know that x times x will give me x squared. I need to multiply to 16 but add to negative 8. So I want negative 4 and negative 4. Because it's x minus 4 times x minus 4, we can write it as x minus 4, the quantity squared. And that's what they meant by perfect square trinomial. Now this is able to be solved with square roots because I have a quadratic term, a squared term, and a constant term. So I can solve by taking the square root of both sides. And so I'll say x minus 4 is equal to plus or minus 5. So I have two equations to solve. X minus 4 could equal 5, or x minus 4 could equal negative 5. So I'll add the 4 and determine that x could be 9, or x could equal negative 1. Using this idea of factoring perfect square binomials into the square of a binomial, we can solve any quadratic equation by using the process in mathematics called completing the square. This method can also be used to transform a quadratic equation from standard form to graphing or vertex form so that we know the coordinates of the vertex. So for our next example, we're going to take a look at trying to find the value of c that makes x squared plus 16x plus c a perfect square trinomial. Then we'll write the expression as the square of a binomial. So if we think about factoring this, we know we would have x times x, both plus signs since they're both plus signs here. We want to add to 16, but in order for it to be a perfect square trinomial, so to be able to write it as x plus something squared, I need the same number here and here. Well, that means I'd need half of 16 in each position, so that together they add to 16 with the same number, so it would be 8 and 8. So that we'd have x plus 8 quantity squared. If we multiplied it out, we'd have x squared plus 8x, which would be the 16x, plus 64. So in order for this to be a perfect square trinomial, we need the constant, the c value, to equal 64. And the trick to how we did that, our constant will need to equal the b value divided by 2, so split evenly, squared. So in this case, our b value is 16. When we split it in half, we got 8. And then 8 times 8, or 8 squared, gave us the 64. This is the trick we'll be using to figure out what we need for a constant to force our expression to be a perfect square trinomial. So the next thing I want you to do is skip over the diagram where we're going to list out the steps of completing the square and do these guided practice problems. These guided practice problems will have you practice what we just did, finding the value of c that will allow the expression to be a perfect square trinomial and allow us to write it as a binomial squared. Pause the video, complete these 3 problems, and then come back and see how you did. Okay, so we've looked at some examples of how to rewrite a given equation as a binomial squared and solve using square roots, and how to figure out what the constant needs to be in order to have a perfect square trinomial. Let's take a look at the entire process of completing the square. So we're going to be starting with an equation in standard form. Y equals ax squared plus bx plus c. In this lesson so far, we'd seen all examples where the a value was 1, but we will move on from that. So our first step is actually going to need to be to divide the entire equation by a. So I'm going to do example 1 as we write down the steps to show you an example of how to do this. So example 1 says x squared minus 12x plus 4 equals 0. Well, the a value is 1, so we can divide every term by 1. It's not going to change anything since we're dividing by 1. But there is our first step in the process of completing the square. Our second step in the process of completing the square is to move the constant to the other side of the equation. We just kind of want it out of the way for now. So to do that, I'm going to subtract the 4. So of x squared minus 12x equals negative 4. And then we're ready for step 3. So step 3 is we need to figure out what we want now as a constant here, so that we have a perfect square trinomial that'll factor into a binomial squared. So we're going to use that process we just practiced in the guided practice problems. And normally, we would always just take this b value divided by 2 and squared. We have to keep in mind, though, that we've divided by the a value from the first step. So, when you divide by a, you would then have b over a. So now we're going to take half of b over a and square that and add it to both sides. So half of b over a would be b over 2a. We're going to square it. We're going to add it to both sides. Okay, so that means we take negative 12 and divide by 2 squared, because the a value is 1 and we've already divided by it. Plus sign there, so we're going to add that to the left side and the right side. Okay, well, negative 12 divided by 2 is 6, and 6 squared is 36, so I'm really adding 36 to both sides of the equation. So on the left side, I'll have x squared minus 12x plus 36 is equal to, well, negative 4 plus 36 will give us 32. So this left-hand side is now a perfect square trinomial. It's going to factor into, well, x times x is x squared. I know I need 2 minus signs here, since there's a minus here but a plus here. So we need 2 negatives to multiply the positive but add to negative 12. And we need 6 and 6 so that it multiplies to 36 but adds to negative 12. Ooh. And I didn't mean 0 over here. Sorry. I mean 32. So now we can rewrite this as the binomial squared. So x minus 6 quantity squared has to equal 32. And that's my step 4. So write the trinomial as a binomial squared. So we've successfully completed the square. We've forced our original quadratic equation to factor into a perfect square. And now I can solve with square roots. I can take the square root of both sides, and so I'll have x minus 6 equals plus or minus the square root of 32. But I need to break down that 32 because there's a 16 inside, so I'm going to break it down into square root of 16 times square root of 2. So x minus 6 will equal plus or minus 4 square roots of 2. And then I finish it off by adding 6 to the other side, so x equals 6 plus or minus 4 square roots of 2. So that's a complete example of how to complete the square and then solve via square. We have an a value of 3. So again, we'll start by dividing every term by 3. So we'll have x squared minus 12x plus 50 is equal to 0. Next step is to move the constant to the right-hand side. So we have x squared minus 12x equals negative 50. Now I'm going to take half of the negative 12, square it, and add it to both sides. Well, half of negative 12 is negative 6, squared is 36. So I'm really adding 36 to both sides. And I'll get x squared minus 12x plus 36 is equal to negative 14. So again, I've got a negative as my constant on the right-hand side of the equation, so I'm thinking I'll end up with an imaginary unit in there. We're going to factor the x squared minus 12x plus 36 into x minus 6 quantity squared equals negative 14, so that we've successfully completed the square. Now we solve via square roots. We take the square root of both sides. So x minus 6 equals plus or minus the square root of negative 14. But we can't leave a negative under a square root, so we've got to break that down into the square root of negative 1 times the square root of 14 via the product property. By definition, the square root of negative 1 is the imaginary unit I. 14 is 2 times 7, both of which are prime, so I can't break that down any further. I finish it off by adding the 6 to the other side, so we have 6 plus or minus I square roots of 14. Okay, example 5 is multiple choice, and it's a little bit of an application problem. The area of the rectangle shown is 72 square units. What is the value of x? Well, to find the area of a rectangle, we have to multiply length times width. So we take 3x times x plus 2, and we know that is supposed to equal 72. So 3x squared plus 6x equals 72. I can solve this with the process of completing the square. I can divide everything by the a value. So we have x squared plus 2x equals 24. I already have the constant on the right-hand side, so I can skip that step. Next, I'm taking half of the b value and squaring it and adding it to both sides. Well, that's really just 1. Half of 2 is 1, and 1 squared is 1. So we'll have x squared plus 2x plus 1 equals 25. So we can factor that into x plus 1 quantity squared equals 25. And we can solve with square roots. So we take the square root of each side. We get x plus 1 equals plus or minus 5. So we have two equations to solve. X plus 1 equals 5. X plus 1 equals negative 5. So x could equal 4 or negative 6, but because we're talking about the length of a rectangle, the negative 6 just doesn't make any sense. So the value of x is 4. If we made x the negative 6, letter D is enticing, but if we plug in negative 6, 3 times negative 6 is negative 18, so your length would be negative 18, your width or your height would be negative 4. It just doesn't make any sense for the dimensions of the rectangle. Okay, so we've done a bunch of examples now of how to take an equation we're asked to solve, use the process of completing the square to force it to have a quadratic term and a constant term, and then solve with square roots. Now we're going to take a look at the second application of completing the square, and that's to take something in standard form and write it in vertex form. So in example 6, we have y equals x squared minus 10x plus 22, and they want us to write it in vertex form and then identify the vertex. So just a reminder, vertex form is when you have an a value times x minus h quantity squared plus some k value. We're going to use the same steps we did before, it's just that now you're going to leave the y value there. It won't be 0, and we won't end up solving with square roots. We'll just end up solving for y. So, first thing we do is divide by a, but the a value is 1, so all of your terms would stay the same when we divide by 1. The next step is to move the constant to the other side. So I'm going to subtract 22 from both sides. So I'll have y minus 22 equals x squared minus 10x. Then I'm going to take half of the coefficient of x, square it, and add it to both sides. Well, half of negative 10 is negative 5, squared is 25. So I'm really just adding 25 to both sides. So y, negative 22 plus 25 is positive 3. So y plus 3 equals x squared minus 10x plus 25. Well, now we can factor that right-hand side and rewrite it as x minus 5, the quantity squared, because it'd be x minus 5 times x minus 5. And I've successfully completed the square. They want me to write my equation in vertex form. I'm pretty close to vertex form. The problem is this plus 3. I need it to just be y equals. So I'm going to subtract 3 to move it to the other side. I can't actually take the 3 away from anything on this side because the exponent would have to come first. I'd have to multiply this all out and then subtract 3, and I don't want to do that. If I do that, I'm going to end up right back where I started, and I want it in vertex form. I've done all of this work for a reason. So we're going to leave it as the quantity squared and just put the minus 3 behind it. So we'll have y equals x minus 5 quantity squared, take away 3, and we can see, oh, here's h. Here's the h value. Here's the k value. So the vertex that they've asked me to identify is 5, negative 3. Okay, so let's take a look at another example of how to take a standard form equation, use the process of completing the square to rewrite it in vertex form, and then identify the vertex. So we're given y equals x squared plus 18x plus 95. Again, this one has an a value of 1, so my first step dividing everything by a doesn't change anything. But my next step is to move the constant to the other side. So we'll have y minus 95 equals x squared plus 18x. Now I'm going to take half of my coefficient of x and square it and add it to both sides. Well, half of 18 is 9, squared is 81, so I'm really adding 81 to both sides. So y, negative 95 plus 81 gives me negative 14. Over here I'll have x squared plus 18x plus 81. So if I factor that right-hand side, I'll have y plus 9 quantity squared. And I finish it off by solving for y, so I'm going to move the 14 to the other side, keeping in mind I can't actually add 14 to anything because this quantity is being squared, and the exponent always comes before addition. I also do not want to multiply this out, because then I'll end up right back where I started, and the entire point is to have it in this form, aka vertex form. So we'll have y equals, I just realized I wrote a y here. And I mean an x. It's not letting me erase it, so I'll just have to write over top. I apologize. That should say x plus 9, quantity squared. So that when I move the 14, I'll have y equals x plus 9, quantity squared, plus 14. Remember that vertex form is a times x minus h squared plus k. So if I've suddenly ended up with a plus sign here, that means my h value must have been negative. Must have been -9, so that minus a minus is how I got to the plus sign. So that tells me my h value is -9, and my k value is 14. So the vertex has coordinates -9, 14. There's my vertex form, and there is my vertex. Okay, so time for another application problem. Number 8, baseball. The height y and feet of a baseball t seconds after it is hit is given by this function. Y equals -16t squared plus 96t plus 3. Find the maximum height of the baseball. Keep in mind that when they ask you for a max or min and you're dealing with a quadratic, that means you have a parabola. In this case, it's a face-down parabola, so you have a maximum, and that maximum is known as the vertex. So if they ask you to find the maximum or minimum, they're asking you to find the vertex. They give it to you in standard form, so you could, of course, use the opposite of b over 2a. Find the x value, plug it in, find the y value. We're going to use this as a good application of this process of completing this square in order to take it from standard form into vertex form, and then we can just identify the vertex. So step 1 is to divide by that a value. It's no longer 1, it's -16 this time. We are going to get fractions. That's a-okay, we can work with fractions. Keep it as fractions, do not ever go to the decimal. We'll have y divided by -16 equals t squared minus 6t minus 3/16. Next step is to add the 3/16 to the other side to get it out of the way. So we'll have y over -16 plus 3/16 is equal to t squared minus 6t. So now I'm going to take half of the coefficient of t, square it, and add it to both sides. So half of -6 is 3, squared is 9, so I'm really adding 9 to both sides. So I will have y over -16. Well, I've got to add 3/16 and whatever 9 is as a 16th. So I'm going to do a little side problem. I'm going to take 16 times 9. So I can get a common denominator and do my adding. Well, 6 times 9 is 54, so I put the 4 down, carry the 5. 9 times 1 is 9, plus 5 is 144. So on the left side, what I'm really doing is 3/16 plus 144/16, because 9 in terms of 16ths is 144/16. So then I will have 147/16. On the right hand side, I've got t squared minus 6t plus 9. So I can write that in factored form as t minus 3 squared. And now I just have to solve for y. So I'm going to move my constant to the right-hand side by subtracting it. Again, I don't actually subtract it from anything, I just put it behind the quadratic term. So we have y divided by negative 16 is equal to t minus 3 quantity squared minus 147 over 16. And I'm almost done, but I still have y divided by negative 16, and I just want y. So my last step is to multiply every term by negative 16. So that means I'm going to distribute negative 16 times this term, which is the quadratic term, and times this term, the constant term. On the left-hand side, negative 16 is really negative 16 over 1. So I'd have negative 16y over negative 16. On the right side, I can't actually multiply the negative 16 times anything inside of here because the exponent has to come first. So I just put it out front and say negative 16 times t minus 3 quantity squared. On the right, I'd have 147 times negative 16 divided by 16. So my negative 16s divide out here, leaving me with y equals negative 16 times t minus 3 squared. Again, the 16s divide out and the two negatives would cancel, so I'll have plus 147. Alright, so we did it. We put it into vertex form. Now I just have to identify the coordinates of the vertex. Well, that's here and here. So the vertex is 347, which means the maximum height of the baseball is 147 feet. Okay, at this point, you are going to try 4 practice problems. So you're going to complete the guided practice found on pages 7 and 8 in your guided practice problems 7 and 8, 13 and 14. They're found on pages 52 and 53 in your textbook. And you're going to write them in the blank space found in your notes right after this baseball problem.